Welcome back to our classroom, and in this video we are going to see about conservation of momentum. Children, try to understand there are some other word apart from conservation. Conservation means remains unchanged, throughout it is constant. It is a meaning, right? Even sometimes they can ask in different manner about this question. Conservation of momentum, the momentum is remains same, or momentum remains constant, or remains unchanged, like that we can say this word, right? Conservation, as I said very clearly, that means remains unchanged. Before going to start about this one, take any two balls, right? You can take two rubber balls. One is, as you can take it as ball A, and another one is you can take it as ball B. For the ball A, you have the mass m suffix A, and for its initial velocity u suffix A. Similarly, for ball B, its mass is m suffix B, and its initial velocity is u suffix B. That's why I have mentioned here before the collision, it has some velocity, initial velocity UA and UB for the ball A and B. When these two balls make a collision with each other, two rubber balls is going to collision with each other. That is the diagram I have represented here. Ball A exerts some force on ball B. That is F suffix AB, force. Similarly, ball B exerts a force on ball A, that is F suffix B. And you can understand here, FAB and FBA both are acting in the opposite direction. As you know, this is the Newton's third law. Yes, and after the collision, it gains some velocity. Ball A has the velocity is VA, and similarly ball B, it has the velocity VB after the collision. And we know that the Newton's second law of motion, that is the rate of change of momentum. The rate of change of momentum is force. So from that formula, we are going to derive the force acting on the ball B by A, and similarly the force exerted by the ball B on A. Both the force we are going to compare and use Newton's third law, and we are going to derive about conservation of angular momentum. And we have let us have some derivation part of this question. I will derive it now. Yeah. Before going to start about this derivation part, we must know about some basic concepts. Yeah, children? Yes. What are they? First thing, what is momentum? Momentum is the product of mass into velocity. What is Newton's second law? The rate of change of momentum is force. Rate of change of momentum is force. What is Newton's third law? Every action there is an equal and opposite reaction, right? If you know about these three concepts very clearly, then this derivation part is very clear. And again, I am saying this definition for the law of conservation of momentum before and after the collision. Before and after the collision, the total momentum remains constant or remains unchanged. Understand the word before and after the collision. Before and after the collision, the total momentum remains unchanged, and the total momentum is constant when no unbalanced force acts on them. Why we have to say this line? If force acting on them, then momentum will not conserve it on it. Yeah, children? Yes? Okay. As we know that in this derivation, we have chosen two different balls, ball A, ball B. And as we know that the rate of change of momentum is force. Velocity is vary with respect to time. Then velocity, rate of change of velocity is acceleration. Mass into acceleration, force. That is rate of change of momentum. Yes. What is momentum? Mass into velocity. Two ways we can say. If you are closing this T, mass into velocity, right? This is final velocity, this is initial velocity. Anyway, this velocity. So mass into velocity is momentum. momentum change with respect to time is rate of change of momentum is equal to force. So FAB, what is AB stands for? Ball A exert the force on ball B, that is action. Ball A exert a force on ball B, that is an action. So according to that, we can write FAB is equal to, so mass of ball A into VA, final velocity of ball A minus initial velocity of ball A whole divided by time. And similarly, we can write the force exerted by ball B on ball A, that is FBA, that is reaction. So FBA is equal to MB. What is MB? Mass of ball B. And VB minus VB. What is VB? The final velocity of ball B. UB is initial velocity of ball B. And with respect to time, so velocity changes with respect to time is acceleration. So mass into acceleration is force. Or otherwise, just close this T. Mass into velocity, correct? This is change in velocity, yes, change in velocity. So mass into velocity, momentum. Momentum is change with respect to time, force, right? And these two forces are action and reaction. And from that, Newton's third law, in every action there is an equal and opposite reaction takes place. So we have, I use Newton's third law, FAB is equal to minus BA. Why? FAB will act this side and FBA will act this side. Both are acting in the opposite direction. So I use Newton's third law. And FAB we have written here MA into VA minus UA divided by T is equal to this minus sign I put here, and FBA we have written here MB VB minus UB whole divided by T. Now we can cancel this T and this T, correct? Yes. So we will have MA into VA minus UA, MB into VB minus UB. So just multiply MA into VA minus MA into UA. Similarly, minus MB into VB minus MB VB, and minus into minus UB plus MB UB, correct? So this minus term should come to this side and this term should go to this side. So minus sign should come to left, comes to left side means it becomes plus, and this value that is minus MA goes to right hand side, then it should becomes plus. So MA VA minus sign should come to this side means MB VB is equal to this minus sign goes to right hand side M plus MA UA plus MB UB. So this is before, correct? Before collision, and this is after collision, right? This part alone after collision, this part alone before collision. So before and after the collision, the momentum remains unchanged. Otherwise, if you sum up the individual momentum value, that is equal to before and after the collision. Yeah, children, have you understood this video, this concept? Yeah. Thank you very much for watching it. See you. Bye bye.